Density for AP is done a little bit differently. In the honors class, we talked about density of just pennies. What I have here is a column chromatography pack. And this material will allow liquids to be separated by polarity and density. So what I have today is grape Kool-Aid. We're going to separate the red and blue dye of the grape Kool-Aid through the chromatography pack. I have set this up by running 70% isopropyl alcohol through the pack and then 10 milliliters of water. So what I'm going to do now is since it's primed, I'm going to inject 1 milliliter of the grape Kool-Aid into the pack. Now when we look at it, you see that the grape is still together, but it is all in one point. So we're going to separate the dye into its blue and red by adding the 18% isopropyl, pushing it through, and collecting what comes out of the cartridge. And it should separate the dyes. So let's take a look. And there's the first couple red drops of the dye into the graduated zone. You can see, if we go closer, that it is separating out into its colors. If I stop it right there, you can see that I've collected the red portion of the dye in the graduate zone. Don't worry about the data. I will make a little separate video showing you the data and the calculations. So what I have left now in the cartridge is the blue dye. If we allow it to push through, there it's blue. It goes from red to purple to blue. There you have the 10 milliliters of the dye. You can see that it's red and blue now. I don't know if you can see that on the screen on here. So you can see where it's separated out. We've separated the two dyes, and now they're not mixed back together. We can shake it up. They'll mix a little bit if we let it settle. So the purple dye is really a combination of blue, and red dyes. So in the next video, I'll show you the calculations and how to get the answer and the values.